So let us assume that we have a function g of x and y, which is a solution to this problem. Let us define the function h of g, or of some, let's call it capital F. Yeah, so capital F of x and y, and say that that is equal to this. All right. Okay. Now what we're going to do is, no, that's not even what I want it to be equal to. I'm talking nonsense. I'm going to say it's equal to that. Now note what it means for this. Now it's going to see what it means for this to be equal to 0. What it means for that to be equal to 0 is that, I don't know the easiest way of getting an imply symbol here. Let's design. Come on, give me an implies. No, I need to go arrows, I guess. That statement, it's long. It did say long, double arrow. That's more like it. That implies that this is equal to 0, which in turn implies this is the case. Therefore, if we find some function such that h of that function is equal to 0, that implies that that function satisfies our conditions given above. Okay. Next step. Let's do this slightly differently from how I did it before. I'm going to consider the following function. F of... no, that's not worth it. That's not worth it. I'm just going to... So, I'm also going to delete this line because it's fairly obvious that h of x equals 0 implies that we have a solution, given that is literally how we defined it. Okay, so what do I now want to do? I think I now literally just want to say, what is h of f of x, comma y? And I take this, drop that in here, but substitute in a lowercase f. Then I'm going to substitute. I feel we can make the step to just substituting this, and I feel this isn't too bad of a step. Oh, wait, no, oh, well, if I do it like that, it will be, because I'm bad. Here we are. Okay, so I'm going to now pull in that minus sign, plus minus that, minus that. I'm going to expand out these brackets. I'm going to try and do my working a little bit more slowly this time, given this is the final solution. And I'm then going to do the same here. I'm going to take f of x plus w, comma y, plus w, comma y, and again x plus w, comma y. Take those, again, expand out brackets, and I'm going to do the same thing again. So everything within these brackets is now going to have y set to y plus w, or y replaced with. Now, if this weren't a video, if this were a paper, I might want to use some, well, honestly, if this were a paper, I would just substitute it in, because it's not too bad to see. Okay, now what I'm going to state, or I'm not going to state, we've already assumed that g of x is a solution to this equation. So what I'm now going to do is, actually I'll keep putting these on new lines. I'm going to pull this minus g of x and y. Okay, that's next to that. That's next to that. Okay, and we're now going to see that, hey, this is the left-hand side of that. So I'm going to substitute. So, yeah, this in particular is equal to this, which is therefore equal to this, which means I can therefore substitute this in. And hey, g of x, comma y minus g of x, comma y. Brilliant. We're now left with this equation. I can take this x squared, I can cancel it with this x squared. Take this y squared, cancel it with this y squared. That's then going to be plus a. Really hoping I'm not mucking up as I go along. Because I have done this math so many times now. Well, not this particular maths, but I've been working with this equation for quite a long time at the moment. I've not been working on this proof for that long, but I've still been working on this as a whole. Okay, this is going to be equal to... Did I muck up last time? No. I couldn't possibly muck up. I wouldn't do something like that. Okay, now I'm going to expand this out. So we're going to get y squared plus 2yw plus w squared. Delete that. And I'm going to do the same with this. Do I want to do that, actually? I don't think I do. That made sense before when I had w squared to hand, but now I don't have w squared to hand. It makes sense to just do this. Substitute w, substitute w. Now notice that this, I'm going to go through this in a little more detail than I have every other time, just so it's clear what it is I'm doing and why I'm doing that. So I'm expanding out these brackets so they both have a minus sign in front of them. And now we're going to have 2x over 2. 2x over 2 is going to mean I'm chucking a 2x up there. And that's going to... That was a plus sign, right? Yeah. It's going to cancel with that. We're just going to be left with x. We can do the same thing over here. I'm going to check. Well, yeah, I'm just going to do the same thing. Okay. Now I want to expand this out. Concerned somewhat by some of the factors. You can tell I'm really doubting myself, because I know I have already mucked up multiple times when trying to do this. I'm trying to solve this problem. Okay, I'm going to note here that these two brackets are exactly the same. They just have x and y interchanged. Therefore, I'm only going to expand these out once. Okay, I'm just going to expand it out once and then just interchange x and y, because those brackets were identical when you interchanged x and y. So therefore, I can. And that will make my life a little bit simpler. Okay, so we're going to get, I don't know why I necessarily wrote that out in full. We're going to get this, we're going to get 2 of that, and we're going to get that. That's going to be that bracket. Okay, and we're going to have this all over again. Just, I'm going to swap every occurrence of x and y. Let's add that on. So I'm going to swap every occurrence of x and y. Well, this one, it doesn't matter if I swap, because, well, I'll do it. Y, x, y, x, y, and x. Okay. We're now going to look at this for a second. We're going to realise, yeah, that really does make no difference, because, well, okay, this is squared, minus 1. Wow, I can't believe I'm showing this in this much precision, but yeah, minus 1 squared. So I'm now going to move that minus 1 inside this square. Okay, we're going to get that. We're going to expand out that bracket, so that's going to look like that. Hey presto. We've got that. We're subtracting that. That's exactly the same as our term out front. So we have that. Okay, and we can do the same again for exactly the same reasons. We can do it up here, or if you prefer, we can do it up there, because these are both identical up to swapping the signs, up to swapping the x and y rather. Okay, and then we can look at these two terms. I'm going to do something telling. I'm going to pull that minus sign out front, and I'm going to rewrite this as minus x plus y. Note then, this term has an, okay, I'll be even more precise about it. I will expand that into both of those. Expand this out. Okay, now let's pull this to the front, and we can see, hey, these two terms are exactly the same and are being subtracted from one another. Let's delete them. And we look at this and we see, okay, this isn't equal to 0. Oh wait, pranked, it actually is. You can tell I'm getting sarcastic now. I've been working this problem for a long time. So, sorry, that's A, therefore it's 4A over A. And hey, we've got 2A plus 2A minus 4A. That's equal to 0. Hence, we have shown that... Oh, this isn't in LaTeX, so I'm not gonna... Or I have a LaTeX-like font for Word, but I don't have it on this particular document. Anyway, hence we have shown that if we have f of x following this definition up above, that it is equal to 0. Hence, if there exists a single solution, g of x and y, then that implies the existence, if g of x of y equals 0, that implies, if h of g of x and y equals 0, that implies that h of g, so that h of f of x, y is equal to 0, which implies that if g is a solution, h is a solution. Therefore, if we have a solution for the function at 0, 0, we know that another solution must be given. So let's now consider f at 0, 0. Well, that's going to be equal to g at 0, 0 plus something. So let's substitute in 0, 0, so those both disappear. Pull out this minus 1. And there we have it. That is our proof that there exists no solution, no unique solution to f for this equation.